Solidity crash course. The Solidity is high-level language for Ethereum smart contracts run on Ethereum virtual machine, used for dApps, voting systems, wallets, and more. Why learn Solidity? Build decentralized systems with real-world impact, growing demand of blockchain developers. For start that, you will need Remix IDE based on browser. For start the programming, we can create a folder and start it. Hello world.sol. The extension of Solidity file must be SOL. Okay, we write the first contract together. First at all, we must write license identifier MIT. After that, we must define the version of Solidity 0.8.0. I write a contract for hello world. I define a variable public greeting hello world. Okay. For deploy of this contract, we must go in this section, check the autocompile, version of Solidity on 0.8.0, click on compile it. In this section, we can deploy the contract. Choose this contract, then click on deploy. The contract deployed successfully. In this section, we can copy the contract address. For example, the address of contract is this. If I click on this button, return me message hello world. Okay. I also can define a function get greeting public view returns the return type is string memory return greeting. When I write memory, this when return the value, the temporary save the variable state to return value public. Okay. This function is for get the result of variable of greeting. I also can define function for set greeting to change the greeting value. I get a value from input of function called data new greeting. Set greeting function with call data for new greeting input. When we can use for call data, when if the parameter greeting equals new greeting. When to use call data? Use the call data when you don't need to modify the data. You want to save gas, you are passing arrays or string for other complex types. You can see key difference from memory. Call data read only, yes. Memory, no. Gas cost, the call data gas cost is lower than memory. Modifiable call data, no. Memory, yes. Call data used in external function inputs. Memory uses in internal function inputs and temporary storage. Okay, we can deploy again. Creating value is this. We can change the message. Change it the message. Then we can change the message in here. Okay, that's fine. This is function get greeting, and also in this section we can get the value of variable. Okay. Let's to learn primitive variables. Okay, I define contract variables uint constant max supply equals 1000. Address immutable, owner. When I define the variable immutable, this variable can be using constructor. Yes, okay. This constructor can be used when I deploy it. I compile that. When I deploy the contract, the MSC sender is the valid address that I used now. When I deploy it, my valid address assigned an owner, this variable can't be shown in deploy section because I don't define this to public. Okay, now I can see it when deployed. Max supply is this, and owner, the owner of contract is this address. This is my address. Okay. The uint is unsigned integer that allow only 0 and greater than 0. When I write negative number like this, not works. But when I use int, that allow the positive and negative values. Okay. I define control flow dot solve. Contract control flow. In this contract, we'll take the variable by if or else conditional. Okay, I define a function check number get unsigned integer number from the input of function. Public returns string memory, because when I return the value, the variable saved temporary, but I use memory in this section. Okay, I write a condition if number equal than 10. Okay, return greater than 10, else return 10 or less. Okay, I also define another function for sum to n. I get unsigned integer from input. Public returns uint. Variable types, we don't need to use memory, only use memory when use string. Okay, uint sum equals 0. For loop, this is example for loop I++. This for loop, it starts from 1 to n, and get value of n from input of function. Okay, sum plus equals I. This variable sum the value of I in every of loop when run it there. In this section, write for me function state mutable can be restricted to pure. Also, I write pure in this section and pure. I write pure in this section because no variable changed state in these sections, but we can use pure. This is internal values, not public variables. Also we can use pure. If I write a variable in here like a equals 10 and edit the state in this section, give me error because I used pure. When I delete pure, not give me any error. Okay, but in this section I don't use any variable in out of function, but we can use pure. Okay, I deployed this contract to test it. Okay, check number. I write 10. This is 10 or less than 10. I write 100 greater than 10. Okay, that's work. I write 10. This compute the sum of numbers from 1 to 10 that equals to 55. We learn the mapping. I write example for mapping. Okay, the version is 080. Okay, contract mapping example. I write mapping, for example, to map address to uint. Okay, define public and variable name is balances. Okay, I also define a function update balance uint amount public balances msc.sender equals amount. Okay, this saves the amount for every wallet. MSC sender is the wallet MSC sender is the wallet address I know use it. For example, in this section I used this wallet. This return the wallet address of this I used. Okay, when I deploy it, I copy of my address, place in this section, returns me 0 because I don't define any number in this section. 200 for example, and check 200. Okay, I can also test other wallet address 0. I define 500 return me, and if I copy this wallet address, return me 200. Okay, this is example for mapping. In the next section we learn struct example.sol. Okay, Prama, the version is 08.0. I define contract struct example. Okay, I define a struct like user with a variable like id string name, and write a mapping for map the address to struct. Okay, I also define public for this. Variable name is users. I define also function add user with the input like uint id string call data name public. The call data, we define call data because I use name temporary in this section. I also can use users MSC sender to save the struct value. For every valid address that interact with country, I can be saved these values like ID and name in this mapping section. Okay, we can deploy it to test it. I add a user with ID 1, name like Alex. Save that. I copy the address, place in this section, return me ID 1 with name Alex. Okay. I also can test with another valid address. I tested, return me empty value. Okay. I define 2 with name like Michael. I define name like Barack. Okay, return me Barack. Okay. In the next section, we learn together Ether wallet. Okay. Parama. The version of Solidity is 0.8. I define contract with name Ether wallet. I define a mapping with point address to uEnt. Balances. I write a function for receive. I define a function to receive payment and save and balances variable. Okay. Define function for deposit. Access modifier public. I define payable to allow pay with wallet. Payable. Okay. Balances. MSC sender plus equals with MSC value. This MSC value get the value from wallet and save in balances mapping. Okay. I also define function withdraw. uEnt amount public. I define a require for check the condition before run other codes in this section. I define condition for that amount must be greater than amount must be lower than balances. Okay. Okay. This is transfer codes. Okay, that's right. I also define function get balance public returns uInt. Okay, this function returns the balances value with MSC sender key to return value for MSC sender. For every wallet separately return the value. Okay, I deploy it to test. For deposit a value, I can change the unit way, Gwei, Fini, Ether. This is Ethereum units, 1 way, and this is 1 Ether. 10 with power 10 power 18 equals this number way. Okay, this is unit of that, and 1 Fini equals to 10 with 10 power 15. Okay, with this number way. Okay, I test the contract. I send 10 Ether. Okay. My Ether value is this with minus 10 Ether. Okay. Get balance is this value. The balance of this wallet is this. And I can withdraw the value 5 and delete one of that 0, withdraw, and this is remaining balance. I check the wallet. The value, the sum of value returned my wallet. Okay. This is a simple deposit and withdraw value in the contract. Okay, that's cool. In the next section, we learn inheritance in Solidity. Inheritance. Okay. Promo 0.80. Okay. Contract parent end public value equals with 100. I write a function for set value. Okay. And I define another contract child to inherit the parent contract. Okay. I also write function for set value. Access modifier public override. I override this function in this contract. Okay. Value equals underline value. Okay. The variable type is end. In this, we must be define virtual can be override that. Okay. I test it. I deploy the child. Okay. I can access to this value because I inherit the parent contract. This return me 100. I can set another value like 2000. Okay. Return me value for 1000 because multiple to 2. Okay. In the next section, we'll learn delegate call. In this section, we can call the function of other contract using delegate call. Delegate call dot solve. Okay. Promo 0.80. Okay. Contract target end public value. I define function set number end value, access modifier to public, number equals to value equals to value. Okay. And also I define another contract that called color end public number, address public target. Okay. I also define a function for set target address to interact with that contract. I get the target address in this section. Access modifier public. Target equals underline target. Okay. And define another function to delegate call set number get end number public access modifier bool success equals with target dot delegate call to API encode with signature. In this section, I write the function name with the input type. Okay. This uint equals to uint 256. Okay. The argument I pass number require success delegate call failed. To check the delegate call works or not. Okay, I deploy the target and then color contract. I copy the contract address of target, set the target in here. Okay, set number like 100. This error occurred because we must be set these variables equals with each other number. Okay, test again. Target color. Okay, this is at target contract address. Set the target 100. This is a multi-signature wallet. In this contract, we can send a value to other wallet to confirm the multiple wallet address. For example, if two members sign to move transaction to other wallet, after that two members sign, the value will transfer to target wallet address. This function is for submit transaction. After that, with this function, we can confirm transaction. Then with this function, we can count confirmation of transaction. After the two members sign, the execute transaction will be run and the value will be moved to target wallet address. Now we can test it. The owner of that contract to transaction to send another wallet address, we can use two wallet address to, for example, this wallet and this wallet for multi-signature contract to send a token or money to another contract. We needs that to confirmation. Okay, I deploy it. I send a 30 Ether value to this wallet address. Okay. Now the value don't move on that wallet and minus from this wallet address, because we should be confirm transaction with two wallet to value move on that wallet address. Okay, I confirm that transaction with this wallet. Okay, now I confirm also with that wallet. Now the value moved on this account. Okay, that's right. In the last tutorial section, we learned voting system. Voting system. Okay. Promo. The version of contract is this. I define a contract with voting mapping address to boolean public has voted. Okay. And also define another mapping for uint to uint for vote count. Okay. And also define uint array for candidates. Okay. I also define event voted address indexed voter uint candidate ID. That's right. Constructor uint candidate ID public. Uint array with memory. That's right. Candidate equals candidate ID. That's right. I define function for voting. Get uint candidate ID public. Require has voted by MSC sender already voted. This condition check that voter already voted or not. Okay. Require candidate ID lower than candidate dates.length invalid candidate. Okay, has voted MSC sender equals true. Vote count candidate ID equals true. Vote count candidate ID plus plus and emit voted MSC sender is voter and candidate ID. I also define function get winner public VO returns uint max votes equals 0, uint winner ID equals 0. For uint I equals 0. Okay, that's right. If vote count greater than max votes, winner ID equal ID. Okay. That's right. Define return here. Okay. I can deploy it to test it. Candidate ID like 1, 2, 3. Okay. I vote candidate like 2. And I can't vote again. That's right. Get winner. Now the winner is 2. With other valid address, I vote to candidate ID 1. Now winner is 1. Again I vote to 1. Winner also is 1. I vote with this winner 1. And vote with this 3. Vote to 3. And vote to 2. Okay. With valid address, vote to 2. Vote to 2. The winner now is 2. And can be vote count. For 1 is 3, for 2 4, 0 is 0. If I vote with this to 0 candidate ID, the vote return me 1, this 4, 3. Okay. I also can check that this valid address voted or not. Thanks for watching to Dapp Smart Dev channel.